Yes, very much choose your own adventure. So I'm Konst, I'm a site reliability engineer. I've got all my links on that site if you want to connect with me afterwards or come see me. I'll be at the conference. So I'm going to talk about quite a large client that I recently worked with, which is a company called Vector. It's a state-owned enterprise that does the distribution of Auckland's electricity, which is quite a large, geographically diverse area, and there's a lot going on. So everything you see in this picture would have been directly or indirectly controlled by the system that we're rolling out. A system called ADMS. It's a new generation of electricity distribution, replacing their old system that didn't have as many clever things, not as much visibility to end users. As you can see, it's a pretty critical infrastructure. If things go wrong, really bad things happen. So for example, the top left is a Huntley power plant, if anyone's been up there. That's a mix of geothermal and coal. They still burn coal. And they get real-time data from our system telling them how much electricity Auckland needs right now, and they adjust how much coal they burn based on that. If you burn too much electricity is pumped into the system, something's going to get a bit hot, and that's a bad thing. If it's not enough, you get brownouts and blackouts. The center of this is the control room. They have quite a few people sitting in this control room. This one is a new control room. That's why you can see there's no one sitting there. Usually it would be manned 24/7 with no breaks. They work in shifts, and there's always somebody sitting at the desk. They have quite a lot of monitors. It's quite a sight to see this raise up. It is a standing desk. You can see it go up, and with all of that weight on it, that's a marvel of engineering itself, maybe more than the system itself. But you can see this, 4 of the screens are on are actually the system that we set up for them. They have a map of the grid, so it has every bit of wire, every bit of transformer, etc. in the system, and they can toggle it on and off. They can see in real time what's happening. They can change the routing, very similar to how IP packets go over the internet. They can adjust things real time. And then you can see there's a purple line or pink line on one of the screens. That's an alarm, so they get alarms when something's going wrong or something's unexpected. So that one is a live system, so there was an alarm on, which is, I'm told, is not too uncommon. We went with a hybrid cloud approach, so there's a lot of different ways to do this. So this could itself be several hours of talk in itself about different ways to do hybrid cloud. But when I say hybrid cloud, it is connecting your on-premise equipment to the public cloud. And there could be other public clouds in there that I haven't listed, a bunch of local providers that some people might be familiar with. And I'm not talking about just using API, I'm talking about a really tight integration where you've got private IPs communicating both ways. So from Amazon into on-premise using a private IP that's not exposed to the internet, and from on-premise into Amazon using private IP that's not open to the internet. Really basic way of doing this, and you can do this in your own home if you want to play around, is to set up a VPN. So you can have your own network on the left at home, and a VPN linking it to Amazon Cloud. And then you've got your own hybrid cloud effectively. We took it a bit further. We used this very specialized bit of equipment from Amazon called AWS Outposts. It's a rack that comes from Amazon, and everything inside the rack, even though it's physically on your premises, so this is inside Vector's data center, Amazon manages the hardware. So you don't get access to the hard drives or to the disks or CPUs or anything that's on there. It's bolted shut, and if you try to open it without the correct key, it will wipe the encryption keys. They take an extreme approach to tamper-proofing this, so yeah, don't. The great thing about this is that everything that you run on there appears like it does in AWS Cloud. So I've got a screenshot of our Amazon console. You use the same Amazon console that you use if you work with Amazon. So the same web interface that you log into, and your instances appear in the same instance, in the same web interface. So you've got, I've blacked out the names of the instances and the instance IDs, but you can see the instance types are much the same as what you might see in Amazon Cloud. Then you can see on the right, there's availability zone. For anyone familiar with Amazon, AP Southeast 2 is Sydney. So it's physically inside Auckland, but it's pretending to be inside Sydney because the way it works is that it's an extension of the Sydney cloud. Each outpost is linked to an availability zone, an AZ. So you can see we've got AP Southeast 2C and AP Southeast 2B. So we've got two different outposts, each one extending different AZs. The reason it's done that way is that the control plane, most of the commands that you send to the outpost actually come from the cloud still. This is what it looks like. So it's probably quite small, but that little purple thing is AWS Direct Connect. This is a dedicated link between your data center and Amazon. It's a physical cable that they connect to your data center, usually a third-party company on Amazon's behalf, and it doesn't traverse the internet. So it is encrypted, but even if somebody intercepted it, it wouldn't be on the internet. So that's actually a requirement for the outpost. And also one of the drawbacks, which I'll get to. So the AWS Cloud has this low latency, super fast link to outposts. And then on the other side, also quite small, apologies, there is the local gateway, which is a special router that's on the outpost, and it connects to all of your on-premise equipment through the usual TCP/IP networking. And they use the BGP protocol to advertise some of the services. The advantage of this is, of course, that the outpost is sitting physically within Auckland. This link that is going over the Tasman, if it breaks, there's actually two links for redundancy, but if they break for whatever reason, then the outpost will still keep running. Everything that's on there will still keep operating. What you're going to lose is you're going to lose the management interface, which is deploying instances and making changes. But you still have access. You can see I've drawn two paths from the devs in the bottom right. One going up to Amazon Cloud, so this would be like Terraform, AWS, SDK, CLI, whatever you're used to interact with Amazon Cloud. And the other link would be a VPN link into the on-premise data center through where you can do SSH or RDP and other similar tools for managing individual instances that are on there. So when that link is severed, it is a disaster scenario because you lose some functionality, but it'll keep running. And as you can see, the really critical links are there, which they will not be severed. If you zoom in, then you can see that on the outpost it's running Amazon EC2, which is Amazon's VMs, Amazon Storage S3. We found that it's not a good idea to actually use too much of that S3 on the outpost because it is quite expensive. The disks that come with it are they're not very big, but default I think it's like 11 terabytes or something like that. You can upgrade it to 33 terabytes for an extra few $1,000s a month. It's pretty steep. Similar with RDS, the Managed Database Service, and Managed Container Services. So there's ECS and EKS for Kubernetes. The control plane will actually be running in the Sydney Cloud, and the instances or the pods or containers would be running on your outpost. When that link is severed, if there's a disaster, they will keep running, but you'll lose some of the functionality that you might be used to with Kubernetes. Right, so I'm not going to cover this in too much detail. We also looked at Snowball Edge, which is, it's a new product from Amazon, the new version of it, compute optimized, comes with 102 CPUs, and you can also host things anywhere you want. This also has the benefit of being portable. It's not bolted to the ground. You can take it anywhere you want. And it doesn't link to the Amazon control plane. It's controlled directly over the network. So that's an extra level of disaster recovery that was considered. Right, so no questions, but I'll be around at the conference if anyone wants to know more about Snowball or Outposts or anything else, or add me on there.
Thank you.
Got a bunch of links.